Hey, I'm Brian Christiansen with SLUG'20. I'm excited to be here, even if it is virtually. Like Jason did in the previous session, just going to go over a couple housekeeping notes. Welcome again to the Slurm User Group Meeting 2020. Okay, so we're on our second session. Next session is Nate Reaney at 10:30 going over REST API. And so 4 separate presentations, 4 separate streams. Presentations will remain available for 1 week after SLUG'20 concludes. Presentations are available through SLUG'20, through the SLUG'20 Slurm YouTube channel or direct links on the slurm.slug'20.com website. Asking questions. Feel free to ask questions throughout the YouTube's chat. Chat is moderated by SLUG'20. Questions will be relayed to the presenter by the moderators. Some may be deferred to the end if they cannot be relayed in a timely fashion. Note that there is about a 5-second broadcast delay. By the time you've asked your question, the presenter may have moved ahead to a different topic and may defer the question until the end. All right, and on with the show. Again, thanks for being here. Excited to talk about some cloud and cloud-related stuff that's upcoming in the next few months, and let's talk about them. Okay, so first, a few years ago, we began working with Google to make it easier to create a cluster in GCP, and we're on our 4th iteration of this work. And these are just wanted to highlight a few of the items that are coming in this V4 release, coming out in February 2021. First, Terraform going GA. We're going to retire Deployment Manager. Pre-made images. So currently, when we stand up a deployment, we take a base CentOS 7 image and install Slurm and other packages, and that can take about 5 minutes, and depending on if you've got GPUs in the deployment, you could add another 5 minutes just installing NVIDIA drivers or OpenMPI into the image. So the plan is to have pre-made images that'll be hosted by SLUG'20, and there will be CentOS 7, Debian, CentOS 8, Ubuntu base images that'll have Slurm and other packages already installed into them. So the deployment will just basically be starting up the images with a few minor real-time configurations like mounting file systems. But this should shorten the time shorten the time of the creation of the cluster immensely, and also scheduling placement policies like placement groups. So having jobs associated with nodes that are located close to each other and in the same network infrastructure, and then also scheduling Google's cloud TPUs or tensor processing units, and then bulk API integration, and I'll come back to this in 1 second, and then also having a marketplace solution so that you can go to Google's marketplace and find, with a web interface, be able to create a cluster filling out a little bit of information, then hitting click, and you'll have a cluster fairly quickly. You'll still be able to do it manually by cloning the GitHub repo and making own personal modifications, or with the pre-made images too, also being able to base a custom image off of those images as well. And then going back to the bulk API integration, so currently when we boot up instances with our Resume program, we end up making batch requests to the GCP APIs, and what happens there is, especially for large numbers of instances, when we get up into thousands of instances, we can batch 1,000 at a time, but one of the drawbacks with that is that even though we're batching 1,000 at a time, each instance creation is counting as one API query. And so what we end up hitting the API query rate of 2,000 API queries per every 100 seconds. So we end up getting rate limited if you are booting up, say, more than 2,000 instances at a time. So, and part of that, we do the 1,000 instances and then we back off. We try sleeping for 30 seconds to avoid getting rate limited. And if there are any if any instances do get rate limited, we put them in a queue and just keep hounding GCP until they go through. So not as efficient, but the bulk API is going to allow us to make up to 1,000 instance requests in one API query. So and then we don't have to. So we can avoid that rate limiting, and we can fire up more instances quicker. And then it also adds the ability to find regional capacity finding. So within a region, it can find instances that within a zone that all have capacity. So just want to demo this real quick. So you'll see that I have 5,000 nodes configured in this Slurm deployment, and I'm going to submit a job that's got 4,500 nodes. So I'm going to go ahead and submit that, and here shortly we should see in the GCP console that this will show 4,500 very, very quickly. So 4,500, one's the compute instance. So that's what the bulk API does, is we can create create large amounts of instances very quickly instead of having to back off and keep trying over and over and over. Now, this job is most likely going to fail because I've got preemptible instances and because the sheer amount of instances being created, that's the job's going to fail because it needs all 4,500 at a time. I wouldn't be doing this big of a job with preemptible instances, but as a demo, just to show how fast this can be created. So these are two N1 standard 2s, so 2 CPU instances with 20 gig persistent disks or drives on them. So do the math. That's pretty cool to have that create that many instances that quick. Okay, so that's V4. We're excited for that to come out early next year. Okay, so moving on to just looking at the other questions. Can public clouds other than GCP be used? Currently, this solution is just GCP, but there are other. Amazon's got solutions, and Microsoft's got a solution. They all have solutions, and using the power save model, following the same example with this resume and suspend program, you can use this with other public clouds. Can the host site host the pre-made images as well? I'm not 100% sure, but I would expect that once you copy it, you could host it yourself. So, okay, so now we'll move into Slurm 2011 improvements. So adding a new feature is dynamic future registration. So right now you can have you can define nodes as in a state future. It leaves them in the slurm.conf, but they remain a future state, which just prevents Slurm CTLD from doing anything, querying them, pinging them to see if they're alive. So we're going to piggyback off of this a little bit and let them be a little bit dynamic. So what will happen is the slurmd can register with this new -f option, and that'll when it registers with the slurmd, the Slurm CTLD will find an available future node that isn't being used, any node that's in a future state, and it'll associate that slurmd with that future node inside of the inside slurmctld. And then on registration, it'll automatically grab the node adder and the hostname registration, which is important for being able to run jobs on those nodes, because it's most likely that the slurm.conf isn't going to know how to talk to those nodes, and especially for srun, the way srun knows how to talk to the compute nodes is through the slurm.conf. And if slurm.conf doesn't know how to talk to those names, then the srun's not going to be able to get the jobs to them. So we have to do this node adder and node hostname registration, and I'll explain that a little bit more in a little bit. And then the future state is remembered. So these dynamic future registrations or future nodes are remembered. Right now, if the node is in a state future and you reboot the slurmctld, those nodes will, and you've taken it out of the state future and said idle, and you restart the controller, they'll go back to future. So if they've registered with the dynamic as a dynamic node, and you restart the controller, it'll stay in the idle or whatever state it was last, and it basically puts it back into service, or leaves it in service. So let's demonstrate that. Okay, so first let's start with slurm.conf. I have two types of instances. This node has 8 CPUs, 1 socket, 2 cores per socket, and 4 threads per core. And then this one is the same thing, just with 2 sockets. So both have 4 threads per core. You'll see how I've got this set up later with cloud. I'm going to demo cloud nodes in this as well. But the future nodes, I've given them a feature, each with future or F1 through 5 and F6 through F10. Okay, so let's go back to the configuration, or to the nodes. Okay, so on Q1, Q2, those are my 1 socket nodes. D1, D2 are my 2 socket nodes. So if I go ahead and just start this up with the -F option, it registered and associated itself with future 1. So if we look at the host name and node adder, we will see that future 1 is now associated with .47 and hostname Q1. And all these other ones, and this is how slurmctld does it by default, is the node adder and the node hostname are the node name if not configured in the slurm.conf. So let's start up this one. So this one I'm going to say, let's start up as F4. So I can dictate which one it is going to show up as. That one might be... Okay, I'll demonstrate that one in a second. Okay, so this one, because it's a 2 socket node, it will show up as a future 6. And then this one will be F9. This one, it's because of the parsing, because of that space. So if we look at this now, so I'm just going to update. Okay. So if we look now, so future 1.47 Q1, we can see future 4 is associated with Q2, and future 5 is associated with D1, and then future 9 is D2. So, and right now, I can submit a job to all 4 of those nodes, and we can see that future 1 is associated with, the associations are mapped up again. So, and then if I were to restart the controller, we can see that that mapping is still there. So, and just as a point out, to explain that alias propagation a little bit more too. So, because srun doesn't know that future 1 is Q1, this is related. This is piggybacking off of the same logic that the cloud nodes do. Is slurmctld by default assumes that the cloud nodes are going to come up with a host name and IP address that Slurm doesn't know about, or that the controller doesn't know about. And so it's assumed that on cloud nodes, when that comes up, that you will let slurmctld know the host name and the address of the node through scontrol. You would do scontrol update node name, whatever, node adder, node host name, and let them know. And then when that happens, so on allocation, slurmctld, so when srun made this request to the slurmctld, slurmctld said, hey, these are dynamic nodes in the allocation. I need to send the aliases to srun. So because srun doesn't know how to talk to the node. So I need to send the IP address and the host name of each node. And then srun takes that information, sticks it in, builds it into its internal configuration so that srun can figure out how to talk to the slurmds. So, and then part of this requires, because the slurmds don't know how to talk to each other, this requires disabling the fan out. So you have to set the tree width 65533, just something big that it's not going to attempt to fan out to the nodes because it'll fail. With this situation, they know not to communicate, the slurmds not to communicate to each other with the tasks and the steps. So after we're done with these, when we want to put them back in the future, we use the update future command, and we're going to put them back into the future state. So now they're available again, and if we do this, we'll see that they get reset back to the node adder and node host name get set back to the node name. So now if I were to, let's start these out of order. So that should get 6, this should get 7, and this should get 2, and this should get 1. And then we'll run our job again, and notice the different mappings. Even though they're associated with different slurmds, we're still able to run the nodes, or run the jobs. So I'll go ahead and put these back into a future state. Okay, so this can be helpful, especially if you have something managing the creation of instances on the outside, and Slurm's not the one that's powering them up or powering them down, as would be done in the power save model. Yeah, so we'll move on to the next thing. So automatic cloud host name and adder registration. So as I explained, Slurm assumes that on cloud nodes that you're going to let the slurmctld know that what the IP address and the host name are of each node. But what we've done here is we've added a parameter, slurmctld parameters, cloud reg adders, and what this does is automatically on registration, the slurmd will get the host name and IP address from the registering slurmd, registering cloud slurmd, so that way you don't have to do these extra scontrol options. And whether you're doing, and just to point out too, if the nodes are resolvable by DNS, these cloud nodes, then you can use the slurmctld parameters cloud_DNS, and then it doesn't have to worry about this alias propagation, and you can use the fan out. But regardless of using that or not, if you want the cloud registration adder, or the node name and node adder and node host name to show up automatically on registration, you can use this option. So and you'll notice that the slurmds were still running, but because they're in the future state, the slurmctld is not going to ping them, and the slurmd is not going to check in. So let's do -n cloud1. So the cloud node registered, and we'll see that it automatically grabbed the .47 and the Q1 from this. So here in my resume time, or my suspend time is set at 30 seconds. So when this starts powering down, so after the node powers off inside of SLUG'20, then it automatically resets the node adder and the node host name back to the node name. So this is helpful, especially if you've got node instances coming and going with different host names and adders. So this percent means he's powering down, and once that clears, then we'll see it go away. And I have a suspend timeout of 10 seconds, so it should clear soon. Okay, so 10 seconds, we'll clear that, and then it got reset back. So that can be helpful and alleviate the need to have to do all those extra S-control updates, especially for a large amount of nodes. That's one less RPC to the SLUG'20. Okay, and then one last option to add. So configurable resume suspend interval. By default, when you're using the power save model for suspending and resuming nodes, there's a thread that's being triggered every 10 seconds by default. So this, and it can happen sooner. If there's any node state changes, it can happen sooner than 10 seconds. So the power save interval, these two options, the power save interval and power save min interval, are to control those timings. So if you want, you could set power save min interval to 10 seconds, and then it would be at a minimum every 10 seconds it would check. And this could be used possibly you could extend this time so that that it's grabbing, so that when you're passing the nodes to boot up to the resume and suspend programs, that it's gathering more instances in their larger requests to the cloud APIs. So yeah, so that is a few 2011 improvements coming that I think will be helpful. And now we'll move into questions. And I've got one. So future registrations alleviate the need for DNS and reverse lookup. Yes. I mean, the future registrations are assumed right now that they're not in. It assumes that they're not resolvable, or the slurm.conf is not going to know how to talk to those slurmds, and so it's going to have to figure it out. It has to use that alias propagation to be able to communicate to the slurmds. And is there a way to keep end nodes always running? Yeah, just in your slurm.conf, just change some of them to a state equals idle or unknown and keep them running. So the question is, any plans for integrating Spot Fleet in AWS? I know Amazon has a solution working with Spot Fleet, and we were talking to them, trying to make that a little better integration. But Amazon, I know Parallel Cluster, I believe it does a power save model and also has. Maybe I shouldn't speak totally, but there may be an option to do spot fleets in AWS. Okay. Okay, with that, I will go ahead and close it. If there's any more questions, there may be coming one right now. That would keep a specific node running, not n of them. So like 10 clouds in a partition. How do I make sure there's always one in a running and idle state? Keep sending a node to it. You'd have to keep. You've got to. So there's a timer on the node which is that suspend. If the node is sitting idle for more than suspend time, then Slurm is going to power it off. So currently there's no way to do it unless you are sending node jobs to it, or you might, I think if you did scontrol update node state idle, that would keep resetting that timer. You could try that. So currently not a way to keep one cloud node idle unless you do something like that. So, okay, with that, I will close this session. So the next session is by Nate Rainey with REST API, starts at 10:30 a.m. Mountain Daylight Time, and is on a separate YouTube live stream. You can see the SCEDMD Slurm YouTube channel for links, or go to the slurm.scedmd.com meeting agenda. And thanks for watching.